I'm going to give you the models I recommend for transcription, or also called automatic speech recognition. My top proprietary models, based on the ones I use with customers, are 11 Labs Scribe V2, and also I use Speechmatics, which I find pretty good if I need to do different languages. In terms of open source models, Voxtrial and Quen models are probably two of the strongest right now if you look at the latest versions. Parakeet, if you need a model to run on device, is still fairly large for a non-device model, 0.6 billion parameters, but very good in quality. And if you need to go a little bit smaller, you can take a look at the Moonshine series of models, which are more energy efficient and faster than Whisper models. Now, Whisper still remains relevant because it's supported with so many libraries and it has a very wide set of pre-training data that leads it to have reasonable performance even a few years later after release. In this video, I'm going to show you the performance of these models on a dataset I've created myself. I've spoken out so that there's a dataset that's not available online that could be pre-trained. And I'm going to talk about how I run the evaluation using Trelis Studio. I'll show you how the models compare, some other tips on the models, and I'll even show you a little bit how to train some of the open source models. If you go to research.trelis.com/ASR-model comparison, you will find my comparison of these models. And I am going to look at them ranked by performance on AI terms, which is a data set I have developed. It was developed by recording myself reading out rephrased news, AI news that has some terms like model names, Claude Sonnet 4.6, for example, benchmark names, terms that are a little bit tricky. This is the public set. You can find it available and openly licensed on Hugging Face, Trelis/AI-terms-public. There's also a semi-private set, which is what I will show the scores for, but that is not being released public for obvious reasons. And there is even a private set that I will not even use for API inference and will only use to evaluate open source models. That will help me the difference between the private and the semi-private tell people are overfitting on the public or worse on the semi-private. So I evaluate the performance of the models on this data set. Just to give you an example, you can see a little bit here, some text. What makes K2.5 interesting is its multimodal capability baked in from the ground up. And you'll see that maybe example doesn't have too many terms. If we go down to another one, Minimax dropped M2.5 as an open source model. You can see here multi-SWE bench, for example, SWE bench. These are terms that are well known, but not necessarily known to models. And not just if I put the text and the text with timestamps, but I've also put in the entities, which is a list of the keywords that are important. And so you can measure the character error rate, not just on the full transcribed text, but actually targeted on those difficult keywords. And that, of course, will always be a higher error rate than the character error rate on the full text, because it's harder to get the entities correct than to get words like the or and or more common words. So here you can see I have ranked the models by their character error rate on this AI terms dataset, but also focused only on the entities. And of the models, if you look at the top, you'll see Assembly AI performs quite well, 2.4%, so quite a low error rate, even on these terms that are quite recent. Voxtrial, an open source model, performing very well. Gemini Pro, Whisper Large and Whisper Large Turbo performing well, which is even a few years after release. Parakeet performing very well, Speechmatics performing well, and 11 Labs Scribe, I would say, is a very good model and performs well across languages too, but not performing quite so well on the character error rate here. Byte Voice, a recently released Microsoft model, and moving down on to DeepGram from Nova. So if I was to look at proprietary models and I can filter them out here, I know this is just one benchmark, and I'm just saying in practice, maybe I don't always choose the best model, but often I will start with Scribe V2, and then I will look at Speechmatics if I want the best performance transcription. Certainly useful in some other languages as well. But that's not to say Assembly AI, quite good, although more limited on languages, and Gemini 2.5 Pro and DeepGram's Nova 3, also good models here. When it comes to the open weights models, Voxtrial is very strong. Whisper models remain strong even a few years later. But if you look a little bit lower and you want a smaller model, Parakeet performs very well. And so if I need to move to something smaller than, say, the Voxtrial model, or smaller than the Quen models, which are also quite small. Although it's maybe concerning that these perform a bit less well on my benchmark. It may be an indication of maybe some overfitting on some benchmarks. I'm not too sure. But Quen models, very multilingual, quite a good option. You can see though, at least the larger one, it's larger than Parakeet, which I think generalizes a bit better. And I'll often recommend Parakeet for on-device applications because it's smaller and it can run with Onyx. Now, if you need to go even smaller, I would often recommend Moonshine, Moonshine Base, or you can go smaller again with Moonshine Tiny, although the performance will degrade a bit more. This model is a similar size to the smallest Whisper models, but it's more efficient and it's faster because it does not force a 30-second window of audio. It dynamically allows a window sized based on your audio input up to 30 seconds, which makes it significantly faster and more energy efficient as well. So my thinking generally on open source models is Voxtrial Quen, if I can use a GPU, moving down to Parakeet, which can be used on GPU, but also will do well even on a CPU. Well, it can do okay on a CPU. It's still 0.6 billion parameters. And then if I want something very small, I'm looking at Moonshine or maybe a Whisper Tiny or base model. I'll just show you how I evaluate these models. So I will use this data set here. And using Trelis Studio, I'll look at the evaluation function. You can try this yourself if you go to studio.trelis.com and log in. You'll need to go to settings and you'll need to set a Hugging Face token so you can push results up to Hub and also pull from private models. If you're training, you can set a weights and biases API key. And if you want to run inference on private models, you may find it helpful to get an API key from Trelis Router. It's like OpenRouter, but for voice. And Trelis Router will allow you to set API keys for a wide range of models, but then access those models through a unified API key and endpoint, which you can create here. And you'll see for now the model supported. If you need more models, you can always file a bug or a suggestion right here. So I've taken my Trelis Router API key and I've put it in here to Studio and I've saved the settings. And with that done, I can go to evaluation, set up the model that I want to evaluate. You can pick a model here. You can pick a model that will boot up on GPU, any of these open source models, or you can pick a proprietary model that will run through Trelis Router. For example, here, let's say I want to test 11 Labs Scribe V2, and I'm going to test it on the public data set here, AI terms on the test split. And I will make sure it gets pushed up to Hugging Face. It will be normalized before the character error rate is calculated. So the text will be lowercase and any special characters will be removed. So you can do that for a comparison. So I'll just get this running here. And this will start to make requests to 11 Labs and get back the data and calculate the performance. If I had instead picked one of these models, say an open source one, it's going to boot up a GPU, it'll run inference there, and then it will perform the evaluation. So you can see it going here on the 11 Labs endpoint. Now, while we're doing that, I'll just mention one or two things about training these open source models. Of course, you can't train any of the ones that are true proprietary endpoints, but you can train any of the Whisper models, the Moonshine models, which I'd recommend if you want the smallest on-device deployments. Then if you want to go a bit bigger, I'd say Parakeet, very strong, supports Onyx, so you can deploy it on the device, very good quality. And if you can go bigger again, if you're on GPU, you can consider Quen 3 or Voxtrial. Something else maybe I should mention is there are some strong models like Omni ASR 7B. This is a massive multilingual model, supports 1,600 languages. It's from Meta. It's too big probably to run in most cases, but it's very flexible and pretty much supports any very obscure language. So if you're trying to use it as a teacher and you need to create some data, Omni ASR can be very powerful for that purpose. Like Voice from Microsoft is not bad. It's also very large, so it's unlikely to be usable if you're going to be trying to run something yourself on device. All right, so the evaluation is done. It actually showed up on this page, and you can see here the model word error rate, the character error rate, and the entity error rate. Here you've got a split by group, so the benchmarks, words that are involving benchmarks, you can see it's making more mistakes than companies, models. It's got a reasonably high error rate, products, technical. So these are the categories of the entities within the data set. And note that here I've run on the public data set, so these scores will not match exactly. with what you're seeing on the leaderboard, because the leaderboard shows the semi-private to try and avoid models just overfitting. One other thing I'll show you is if you do want to prepare a data set, you can go to data prep. You can upload a file here, for example, an audio file, which I'm doing now. So here I've just uploaded quickly a short audio file, and I could upload a VTT transcript and it would be paired, or SRT, or even text, and it would be aligned. But if you don't have a transcript, you can decide to transcribe the model yourself. For example, here I could decide to use the Mistral model. So if I just transcribe with that, I can set the VAT threshold. This will also remove any gaps of silence of 2 seconds or less, or more rather. So here, if I transcribe, it's going to take the audio, it's going to transcribe it, and then I'll be able to review the transcript, which I'll show you in a moment, and see if I need to correct anything, and then save it. And when I save it, I'll be able to push that data set up either as a train validation test split, 80-15-5, a train split only, a test split, and use some advanced settings, like if I want the chunks to be between 20 and 30 seconds, if I want to pack smaller chunks, if I want to clean the audio, enable quality filtering to provide a min or maximum characters per second, and I can just process the data set. So here what's happening is there's a GPU being booted up, and it's going to use Voxtrial to transcribe. Voxtrial is a pretty good open source model. So I should shortly have some text that I can review. And I'll just show you here, I probably won't run it, but if you do generate a data set, you can further filter that data set. So you can take an existing data set and you can filter it using some other model. It's called a draft model here, but this is a second model. You could use a Speechmatics model, for example, 11 Labs Scribe V2, and it's just going to run that model over the existing audio, and it's going to calculate a transcript. And then basically I'm looking for agreement between the original transcript and this draft or filtering model. And where the character error rate is below a certain threshold, I'm going to keep the samples and I'm going to throw out the samples that are higher. So I'll do this in more detail in another video, but it's actually really powerful. If you want to prepare a data set, you draft the transcripts with a draft model, ideally a strong one, and then you use a secondary model to score that and see what the character error rate is. And for the low character error rate rows, you keep those rows and you can use it then. You keep those rows and you can use it as a high quality data set. So back here, you can see that our audio is being transcribed. It's preparing a sample here. It's loading the model, and shortly that should appear. And here you can see that the transcript has appeared. You can review and edit the transcript using this dataset viewer. You can take different speeds, and you can just make edits here and then save if you do make changes. And when you go back, you can now do that data preparation. So I'll go down after picking my options. If it's a test split that I want to use for evaluating, then I'll select test split only, set my advanced audio settings, and do process dataset, and it will push it up to hub. So this is how I created. I actually created a larger data set with full data for public, semi-private, and private, pushed it up to hub, and then I just split the data set after analyzing the entities so that I have different entities in each part so that people can't just simply train on the train split and then get good performance on the test, or the train on the public split and get good performance on the semi-private or the private. So that's just an insight into how I prepared the data for the eval comparisons that I did of these models. And that brings me to the end of my review on ASR. Obviously it changes as new models come out, but for now, models I use most often: Proprietary, 11 Labs Scribe V2, Speechmatics, and then for open source, I recommend, if you've got a GPU, Voxtrial and Quen are going to be options. If you need to go smaller, go to Parakeet, which can run on Onyx on device. And then if you need smaller again, go to Moonshine. Remember that Whisper is still often useful just because it's got such good library support. You can check out these benchmarks, research.trelis.com/ASR-model-comparison. You can try out Trelis Studio for evaluation or training or data prep, and you can try out router.trelis.com if you want a single endpoint to access your API keys for different voice providers. Let me know questions below as usual. Cheers, folks.